Chapter 11, Liquids and Solids, Exercise 11.65. This table displays the vapor pressure of ammonia at several different temperatures. Part A. Use the data to determine the heat of vaporization of ammonia. We have temperature and pressure. I'll copy and paste it to Notepad, and then I copy and paste this to Excel. The reason I don't copy this directly into Excel is if I do that, those will not be numbers, those will be text. So over here, Kelvin, this is pressure, torr. The plan is to plot this LMP versus 1 over T. Alright, and then we'll get the slope. The slope times negative R, the gas constant, is the heat of vaporization. Now, why is that? Well, you'll have to take physical chemistry to prove this. But now we're gonna just use this. What's 1 over temperature? I'm gonna use the equation 1 over 200 here, and then I drag it down. And over here, LMP. Supposedly it should be LMP divided by units, so I'm gonna just use torr for convenience. You can use pressure over 1 bar, over 1 atm, or over 1 torr. It does not matter. It's not gonna affect the slope. You will get the same slope. It's just when you divide pressure by different units, you get different intercepts. Alright, so the natural logarithm of this, and then I will drag this down. Okay, you can see the higher temperature, the higher vapor pressure. So now let's select the data, insert. We plot this. Alright, I'm not gonna label the axis because the goal is just to get the slope and then multiply the slope by negative R. So let's determine the slope. Hopefully we'll get this linear, more option, display the equation, display R squared. Alright, we've got the equation. Let me make this a bit larger, the equation. Home, let's use font size 16. Alright, clearly we see the slope here, negative, this is the slope. The slope multiplied by negative R is the heat of vaporization, so equals the slope. Alright, times negative R. Over here we're going to use 8.31446 in joule per mole Kelvin. Alright, so this is the heat of vaporization. We can convert it to kilojoule per mole. It's pretty simple. It's just this divided by 1,000, we get kilojoule. So 24.7. 24.7. That's it. Uh, 24.7. Are there other ways to get the answer? Actually, in Excel, I think there's a function called slope. So we'll get slope directly. And then you get y is the horizontal axis, comma, and then we select horizontal, vertical, and then horizontal, I believe, and then you get the slope. And over here it's going to be the slope times the ideal gas constant. And again, this is in joule per mole, but if you want to get kilojoule per mole, you need this divided by 1,000. So this divided by 1,000. All right, you get the same value, 24.7. Okay, let's see. Determine the normal boiling point of ammonia. So what's normal boiling point? That's the boiling point of ammonia under 1 atm. So really, we just look at the table. We just need to extend the table. When the pressure reaches 760 torr, that's the normal boiling point. All right, so over here it's gonna be 760. So let's also do this. 760, that's gonna be the pressure, and we have this value, and this value is the value of Y here. So I didn't label this, but maybe I should. Let's add some title here. So this is logarithm of P over torr. Alright, and this is 1 over temperature. Okay, so when the Y value is this, we're just solve for X, and this X is 1 over the normal boiling point. That's it. Alright, so we're plug it in. So we'll solve this equation 6 point, or copy this to the calculator. Alright, it's equal to negative 2969.9, alright, times X, and then plus 19.036. So I'm just using this equation. I'm plugging the value of Y. Y is the logarithm of P, and P is this, logarithm of P is this. So we'll just solve this equation. How do we solve this equation? Let's do this. Both sides minus this. Okay. And then both sides divided by this. We'll get X. Alright. So we'll have both sides divided by this. I'm going to use a pair of parentheses. Divided by that will be X. Okay, this is going to be X, horizontal axis. And remember, X is 1 over T. So this is 1 over T. Is equal to this. Now, what is T? We'll flip this again. Easy way is to do this. This is going to be T. Alright, T is this. 239 Kelvin. Alright, let's double check. 239 is higher than this, and you can see 230, 235, and then 239 will get higher pressure. And with the pressure, the vapor pressure reaches 760, it's going to boil under normal pressure. Alright, 239. Oh, 240. So I think it's pretty close. We got 239.46.